Another youngster, so many youngsters today, which is a surprise to see in a CBG webinar. It is supposed to be a game which mature people play, a tough game. Sai, I'm going to give a brief background. I want him to say a few things about what he has done, because he has done something very important in the entire ecosystem of CBG. His PhD, he told me yesterday that he is just about done his PhD. Only the last, I think, presentation or something is pending. That's what he says. And he is with this interesting firm called Energy Dynamics. The reason I want him to say a few words about himself and what he has done is he seems to be one of the first guys in the country to have done a lot of research at a PhD level on pre-treatment of cellulosic biomass. If am I correct, Sai? So I think that's exciting, because unless you get the pre-treatment correct, I have a feeling that we are going to talk a lot but achieve very little. So my pleasure, Sai, once again to invite you to this webinar by HelloCBG. I request you, Sai, take the first 3-4 minutes, say something about yourself, what you have done in your university in terms of research, and where do you see the whole thing is going, the research. You also mentioned yesterday that you guys have patented it, given the patent a few others. I think audience would like to know what you have done. And then I'll really like you to say something about the pre-treatment, yields, fertilizers, and CO2 generation from cellulosic biomass like Paddy straw, Napier grass. On to you, over to you, Sai. Thank you very much.
Okay. Yeah, thank you, Narsi, for introducing me. And thank you once again to invite me and give me this opportunity to present me and my company on this forum. So I basically, I was an academic and then I shifted to industry. So during my research in Agarkar Research Institute, I was associated with optimizing the CBG production from various feedstocks. So with that experience, I have now joined Energy Dynamics, and I am here now been tasked to look after the commissioning of the plant and look after the healthy state of the digesters. So I'll start my presentation. Shall I share my screen?
Yeah, sometimes you have to wait for a couple of seconds.
Oh, yeah.
The usual network issues. Go ahead.
Okay. So for today's topic, I'll be presenting on the yields and technology associated with the CBG production from paddy and Napier grass. Yeah, next.
Next slide, please.
So our two star products I say is paddy and Napier grass. So let's talk about the positives of both these field straw. Paddy straw is basically the residue that is left behind in the field after the rice has been harvested. So in India, as India is a major cultivator of paddy, so around 120 million tons of paddy straw is being generated in India, and it is majorly composed of lignocellulose, cellulose, hemicellulose, and lignin, and it also has a certain amount of silica. So the major advantage of paddy is that it is abundantly available in the northern states, especially in the northern states of India. And if we look at the biomethane potential of the paddy straw. The conservative value says that around 200 to 250 meter cube of CBG can be extracted per ton TS of paddy straw. Now, paddy straw requires pre-treatment, and if we rightly give the, if we rightly select the technology to pre-treat the paddy straw, we can expect that the BMP potential, the biomethane potential of the paddy straw can be increased somewhere around 10 to 30%, which will help us to, garner some more, product. Now, recently, what has happened in the market is steam explosion technology is gaining a lot of interest for pre-treating this paddy straw. One of the example is bio extruder that the people are trying to incorporate into the ecosystem. Now, talking about Napier grass basically is an perennial forage grass. So once you plant it, it can be, you can take harvest for multiple years. So you don't have to replant it. And if we talk conservatively, around 80 to 100 tons per acre, generally we can harvest it. The yields may be increased if we properly supply with it with proper water and fertilizers. Unlike paddy straw, Napier straw is a bit higher. It contains a high amount of moisture, but it is also a fibrous material containing of cellulose, hemicellulose. One advantage of Napier grass is that it also contains few amounts of proteins, so which has an positive effect on the methane percentage in the biogas. Talking about its cultivation, it can grow on marginal lands and it does not compete with the food crops. So that gives it a positive aspect. And talking about its biomethane potential that we can extract from Napier grass, it is marginally higher than the paddy straw because Napier grass structure is not that complex compared to paddy straw. And the better way to store and to improve the digestibility of Napier grass, it is better that we chop it or ensilage, silage it so that it becomes easier for its transport and also in the process. And what people usually do across globe is that they incorporate cow dung or poultry waste along with Napier grass so that it stabilizes the reactor with respect to microbial population, and the yield can also be stabilized. Now, talking about the positives of next slide. Now, as we say that every coin has a two sides, so though this feedstock have their respective positives, there are also challenges associated with them. So, in case of paddy straw, paddy, since it has a complex structure with a covering of silica, that usually causes clogging in the digester, and in some cases, it also leads to wear and tear of the agitator blades. So to overcome these challenges, there should be a fixed maintenance, SOPs in the for the CBG operators, and those SOPs should be rightly followed so that there won't be any downtime in the digester, a long phase downtime. Another problem with paddy straw is that because of its complex structure, it becomes really difficult for the microbes to attack the biomass. So pre-treatment is a must for paddy straw. And what usually the industry standard is physical type of pre-treatment is been used throughout industry, wherein we reduce the size of the paddy straw. And now recently, as I've earlier mentioned, steam explosion technology has been introduced, wherein under pressure and in the presence of hot steam, the complex structure of this paddy straw has been damaged so that it becomes easier for the microbes to attack it and try to extract energy. Now, another aspect of pre-treatment is chemical and enzymatic, as was rightly mentioned by the previous speakers. Now, this chemical pre-treatment needs to be studied in the near future. Now, the last problem with paddy is that between the different varieties of paddy, the nitrogen content varies. So what happens is, as paddy is rich in carbon and it has less amount of nitrogen, so every batch of paddy needs to be properly tested, and accordingly the nitrogen balance should be maintained. If we don't test this regularly, what happens is then the extra amount of nitrogen goes into the digester, which ultimately leads to excess amount of ammonium production in the digester, which eventually sours the reactor. Now, talking about paddy straw, talking about Napier grass, it also has its own negatives. So, what the first negative is, Napier grass being rich in moisture. So, what happens is the transportation cost. So, whatever we are transporting Napier grass, we are basically transporting water. So, in order to control our transportation cost, it is recommended that we chop it or dehydrate or silage the Napier grass, so that our transportation cost may be limited and we can transport more amount in a same truck. Another problem is Napier grass is it has a fibrous nature. So though it is better, it is more easy to degrade compared to paddy straw, but its fibrous nature may create problem in the digester. So it is always better to enrich fiber degrading organisms in the reactor, or try to augment it with externally with fiber degrading organisms. This fiber degrading or this fibrous nature of Napier grass also leads to scum formation, a thick layer of floating layer of scum formation in the digester. So again, like paddy straw, we also need to have a digester maintenance SOP, and that needs to be properly followed, so that we don't end up in creating a problem for our digester. Next slide. Now, talking about what are the parameters, the process parameters of an ideal healthy running digester. So this is from the literature. If the technology, if the anaerobic digestion technology is of the mesophilic range, then the digester temperature should be around 35 to 40 degrees Celsius. And if the technology is thermophilic based, then the temperature of the digester should be around 50 to 60 degrees Celsius. In both these technologies, the pH would be should be around 6.8 to 7.4. Now, this range of pH is ideal for methanogenesis. So, if your digester pH is not in this range, then the methanogenesis step won't happen, and you will not get the desired amount of methane. Now, another aspect is to maintain the carbon to nitrogen ratio. Now, ideally, it should be around 25 to 30 is to 1. That means 25 to 30 molecules of carbon for each molecule of nitrogen. Another aspect that people generally overlook is carbon to nitrogen to phosphorus ratio. Now, to have an efficient methanogenesis step, wherein the ideal amount of methane is produced, phosphorus is also important. So the ideal range is around, for 120 molecule of carbon, you should have 5 molecule of nitrogen and 1 molecule of phosphorus. Now, talking about the retention time. So what for how much period of time the substrate should be in the digester. So there are basically the retention time has been divided into two steps. So if the technology is high rate technology, so that means the HRT of the digester is somewhere around between 15 to 30 days. And if the digestion process is under a slow state digestion, then the HRT is generally around 30 to 60 days. Now now to maintain, to see whether the feed that we are feeding into the digester, is it appropriate or not, there is one ratio that needs to be seen, is to check the alkalinity and acidity of the ratio. The alkalinity is to acidity ratio of the digester, and this should be around 0.3 to 0.4. So if the value of acidity to alkalinity ratio is below 0.3, this will indicate us that the reactor lacks biomass. So that means that you are feeding too less amount of biomass into the digester. And if this ratio is beyond zero point 0.4, so this will indicate that the digester is overloaded with biomass. So according to this ratio, the feeding strategy or the feeding pattern of the digester should be optimized. Now, VFAs are one of the most culprit molecules in the digester, which actually has it has a negative effect on the overall performance of the microbes into the digester. So generally, the VFA concentration in the healthy digester should be somewhere around 50 to 250 ppm of acetic acid. Basically, it is calculated based on acetic acid. Now, this concentration, if it goes beyond 1000 ppm or mg per liter, then that is the inhibitory, it has an inhibitory effect on the methanogens. So, recovering your digester beyond that point becomes a really challenging task. So, this concentration needs to be properly monitored and it needs to be controlled. Similarly, the alkalinity of the reactor should be in the range of 1500 to 3000 ppm. Another thing is if we overload our digester with lots of nitrogen in order to balance the C bind ratio, if the nitrogen content increases into the digester, it leads to ammonium formation. Now, this ammonium needs to be in the range of 50 to 1000 ppm. If it goes beyond that, then ammonia also has a negative effect on the methanogens, and your methane production process stops. Another thing that is generally overlooked is the hydrogen percentage in the biogas. Hydrogen also has a now hydrogen here has a negative impact on the bacteria. So in the digester, if the hydrogen percentage goes beyond 100 ppm, your bacterial population, which are the first microbes attacking the biomass, their activity slows down. Eventually, methanogens don't get any substrate to convert it into methane. So hydrogen should also be monitored into the digestion and should be in the lower range. Now for paddy, if we talk about paddy and Napier, now paddy being complex in nature, its retention time should be somewhere around 30 to 60 days. And since it is rich in carbon and it has low amount of nitrogen, nitrogen balance is compulsion. So you need to balance the nitrogen content in the paddy. Talking about Napier grass being is pretty easily digestible. So we can keep a high rate of HRT of 15 to 30 days for it to get properly digested. And generally, some varieties of Napier has an ideal range of C band ratio. So in most of the cases, nitrogen balance for Napier is usually not required, but then still we need to keep a check on nitrogen content of each batch of Napier grass. Next slide, please.
Sai, if you can conclude in the next couple of minutes.
Yeah. Now talking about the yield of CBG from paddy and Napier. So for 100 tons of paddy, we can expect around 10 to 12 ton of methane and some 20 to 27 tons of CO2. And talking about the digested FOM, it's generally it comes out around 47 to 52 tons of solid digested. And talking about LFOM, usually in the paddy straw process, the slurry gets recirculated. So that usually depends case by case basis, but it would be in the range of 0 to 50 tons. Now talking about Napier grass, from 100 tons of Napier grass, we can expect somewhat around 3.7 to 4.6 tons of CBG and 8 to 11 tons of CO2. And talking about FOM and LFOM, some solid digested comes out around 12 to 16 tons, and LFOM comes out around 50 tons. Now, what has happened is in this process, only methane is the star product that is usually being sold. So as it was rightly mentioned in the earlier session, FOM and LFM should also be commercialized, and it also needs to be sell at a premium price. Along with that, I just wanted to highlight that carbon dioxide coming out of this digester is also of a biological origin. So that also needs to be promoted, to be added into the food and beverage industry. Next slide, please. Now, in India, government has set up certain guidelines for the use of FOM and LFM as in fertilizers. So these guidelines are as per IS standards, and it is publicly available, so people can go through it. The only thing that needs to be taken care of is the presence of heavy metal in the in the fertilizer, so that we don't put in heavy metals into our food chain. Next slide, please. Now, this LFOM coming out of the digester, as it was rightly discussed in the earlier session, it is actually a good source of organic fertilizer because it has all the nutrients in its bioavailable form, because it has been derived, or it has been all the nutrients like nitrogen, phosphorus, ammonia, some trace elements like calcium, magnesium, all these are the byproducts of a biological process. So eventually it is more easily available to the plant, and plant, if you apply LFOM and FOM into the farm fields, it is more easily acceptable or absorbed by the plant as compared to chemical fertilizers. Second thing is, the pH level of this fertilizer is around in the alkaline range. So what happens is, if a soil, if certain area soil is acidic, it acts as a buffer and it stabilizes the fertility of the soil. Another, and the main, talking about the environmental benefit of LFM is it closes the loop. So you are extracting carbon from the soil, and you are again putting it back in the form of LFM. Next slide, please. So before ending my talk, I just wanted to touch upon what are the latest developments happening in around the globe with respect to CBG production. So around the globe, people are trying, doing all of R&D work in trying to increase the output of the of the CBG plant. So I have categorized them into four different categories. The first category that people are working on are on augmentation. So they are augmenting the digesters with biological agents which will enhance the microbial diversity. They are adding biochar in the which has a direct effect on neutralizing the toxic effects of pollutants. People are also adding some trace elements which are beneficial for the growth of methanogens. Talking about the pre-treatment of the biomass, people are working on different enzymes, different microbes like anaerobic fungus, aerobic fungus, trying to treat it outside the digester in a biological way so that it gets easily degraded into the digester. People are also working on mild acids and alkali agents so that the biomass gets properly treated, with respect to automation and monitoring all the parameters of the digester, because it is a heavy task. It is which is more majorly dependent on human. So to decrease the human interference or human errors, people are trying to automate most of the putting in sensors into the digesters and trying to automate the process. So various sensors, so monitor the physiological parameters, pH and temperature sensors are incorporated into the digester, and to monitor the gas composition and gas flow control, and online GCs are introduced so that less and less human intervention is needed. And talking about some the next generation technologies, people are using algae-based biogas upgradation systems. Then they are injecting oxygen into the digester in a controlled manner so that the polluting compounds being generated in, or any toxic compound being generated in the digester, that gets neutralized there itself. Then there is a company called Electroarchaea, which is using the CO2 coming out of CBG plant and mixing it with green hydrogen to produce methane, thereby increasing the production of methane. And there are some mathematicians and statisticians who are trying to develop a mathematical models to rightly predict the methane generation depending on various feedstocks and various concentrations of feedstock, mixed feedstocks. So this is a positive hope that if people are working across the globe on advancing the CBG production, there is a ray of hope that even in India we will succeed in CBG production. With this, I conclude my talk. Thank you.
Thank you, sir. Thank you very much. That was a really immersive presentation. Now we have next Mr. Sankalp Pathak of GPS Renewables for Technologies and Solutions to Improve CBG Yields. I would like Nursi to say a few words before we start.
Thank you, Sai. Thank you very much. I know you have a lot of details, and I'm sure you could have continued your presentation even for the next 1 hour with a lot of valuable information. Of course, I have quite a few questions for you. Some of them are very specific. Maybe some can be answered after this talk by Sankalp. Both of you can answer, but I'm sure many are going to get in touch with you with very specific questions. You guys are doing a wonderful job, Energy Dynamics. I know it's hard work. Not everything is known. Thank you very much for your time. My pleasure now to invite Sankalp. Sankalp, well, I was just looking at his profile yesterday on LinkedIn, and I also had a brief chat with him. Very nice to once again see people who could have done many other things in their lives with their background and education, really is locking it out. From what I saw yesterday, Sankalp has done a good amount of work, almost 10 years now, in the domain of biogas, biofuels. He has been with the GPS now 6, 8, 7 years. So that's a lot of time. GPS itself is it's just out of the startup mode. So he has been with GPS for a long time, which I think would have given him an excellent bird's eye view of how things are happening. Unlike working in a very large company where you do only a few things. If you're working at that time, GPS must have been small when he joined. Now I know they are much larger. And a startup with a small group of people, I think he would have been exposed to a number of things across the entire biogas CBG value chain. My pleasure now to invite Sankalp. Sankalp, please do say a few things about yourself. I see even after my requesting all these guys, they're very humble and modest. They talk only about their company, which is all very good, but also say a few things about what you have done, what your passion is, what your interests are, a couple of words so that people also get to know you. And I'll be very happy to learn from you, like we did from Sai, some of the emerging technologies, solutions to enhance the total amount of the CBG we get. Over to you, Sankalp.
No, thank you. Thank you, Nursi, and thank you, HelloCBG, for inviting us and give us an opportunity to discuss with a broader audience about biogas and biogas technology. So just to add, I am a microbiologist. I have done my MSc microbiology from Shivaji University. And just small correction, I've been working in biogas field for last 17 years now. So I started my career with Agarkar Research Institute as a research student working on uh, biogas from pressmud cake. And now with GPS Renewable, I'm working as a VP Bioprocess for, and my group is responsible for the yield and biogas production across the plants which we are currently operating. So can we move on to presentation, please?
Can we have the presentation loaded? Thank you.
So good morning all. I will just take a few minutes to discuss about my company, and then we'll move on to topic. The topic I have selected has three parts. First, technological advances in pre-treatment and biogas production. Second, membrane technology and its how it works. And third one is FOM and LFOM and current status and some problem faced with that. So we'll go sequentially. Yeah, next slide, please. So this is a very brief overview of the company. GPS has been always been driven by the technology. So we have already 3 patent obtained, number of patents in pipeline, and very strong D&E team in addition to our bioprocess team. And also we are deploying pre-treatment technologies for lignocellulosic biomass, either thermophilic or anaerobic fungi based, which we will discuss in upcoming slides. Plus, we have our own climate software lab, which supports overall the our company in managing the data and managing the task around whether it is the execution or whether it is the O&M. Then we just to mention few words, we have installed Asia's largest CBG project based on SSO. Then we have installed fastest executed CBG project in Uttar Pradesh. Then Provebs is a technology company in GPS. It's now a subsidiary of the GPS. In addition, we have our project development arm where under which we will be owning biogas project with uh, uh, OMCs like IOC, VPCL. And plus, we have our own division for specialized project which support in improving the gas yield, under which we offer membrane technology, and some other products are under development which will help in improving the gas yield. Next slide, please. So this is first topic, innovations in pre-treatment and digestion. So next slide, please. So few words about why pre-treatment is required. This is a typical composition of lignocellulosic biomass. It is across the spectrum of all kind of agro residues and partially for Napier grass also. So typically it has cellulose, lignin, and hemicellulose. It is bound material. So here minimum pre-treatment, physical pre-treatment is always required because typically biomass is captured in the form of bales. On the plant we receive huge bales, maybe rectangular or spherical bales. So those debaling followed by shredding or hammer mill to bring material in a smaller size which can be handled in downstream process is compulsory. It needs to be there. Then there are other pre-treatment which come after physical pre-treatment. It can be chemical, it can be physiochemical, it can be biological. So chemical and physiochemical will be energy intensive, plus chemical pre-treatment tend to develop lot of waste material which need to be further treated separately. So I think that problem is already being faced in 2G ethanol industry. So our focus area is towards biological pre-treatment. So after once material is made to the smaller size which can be handled with current technology, then we will move on to the biological pre-treatment. Next slide, please.
Can we have the next slide, please?
So this left side of the slide shows the 4 steps of biogas process, which I believe most of us will be known about it. So I won't spend more time on latter 3 stage. We will spend some time on first stage where we want to have a pre-treatment. So the system which we are working on and proposing is the mesophilic anaerobic fungi based system, where at an mesophilic system, anaerobic fungi will be cultivated along with material, which will then work on lignocellulosic biomass to break down the bond between lignin and cellulose, hemicellulose, and further producing sugars. And once these sugars are produced, then it will be a conventional biogas product where sugar will get converted to volatile fatty acids, then volatile fatty acid will get converted to acetate H2CO2, and finally we produce methane. The system here, it's totally biological, and once we have a material which can be handled in physically, then the system will work. So can you move to next slide, please? So these are the benefits of this system which we are proposing. It is working at ambient or mesophilic temperature. Then we do not need chemical or thermochemical treatment, which will avoid means it will reduce the lot of energy use. Also, we will not produce unwanted chemicals. It definitely gives higher biogas yield because material, the sugars present in the lignocellulosic biomass are available for further degradation by other bacteria. AF works by dual action. It has a physical penetration where tentacles, just I'm using a simpler word of this fungi, penetrates into biomass and it also releases external enzymes. It's called a cellulose battery of enzymes where it breaks down the bond between lignin cellulose. It releases cellulose, hemicellulose in the atmosphere, in the nearby environment, in the slurry, and then it can be attacked by other bacteria. It's a natural process. It's happening like anaerobic fungi initially were used to improve the digestion in cows. So it's totally natural process. It do not have any environmental harms. And then since it is a biological process, it's multi-substrate. It need not means even though it need not to be restricted to single substrate, we can work on multiple substrate with it. And the only point here is limited expertise available in field. So we are working towards to build expertise around that also. Next slide, please. So now this innovation, what I talked is about how we can get maximum biogas from the lignocellulosic biomass. In upcoming slide, I will talk about how we can extract that methane to produce maximum CBG from it. Next slide, please. So this is very fundamental. I thought I will spend a couple of minutes on explaining the technology at fundamental level about membrane technology. So we have this wording compressed biogas. It's raw biogas, just not to confuse with CBG. It is a raw biogas compressed at about 10 to 14 bar, and it is passes through the polyamide hollow fibers. These fibers are selective fibers. They allow gases like CO2, O2, moisture, and H2S passing through their pores, and methane, it comes out as a retentate. So what we get at the outlet of this system is methane rich gas which have maximum methane percentage and some portion of CO2. Since it also removes H2O and H2S, we make sure that after this treatment biogas is in compliant with the CBG requirement from the government. Next slide, please. So this is the most used configuration for membrane system, where feed gas initially treated for reducing the H2S concentration. We need not to bring it down to zero. We can have some H2S which can be separated in membrane, and plus moisture brought it down to the level up to, let's say, 1000 ppm. Then we compress the biogas up to 10 to 12 bar, and it passes through the first stage. First stage gas, we take out off gas, which is released to the atmosphere. Typically, it will have up to 2 to or up to 4% of methane. Balance is CO2 and other trace gases. And outlet of first stage goes into second stage, where it is a same process happens. We further concentrate the methane to give us a product gas, which is 96-97% methane, and the outlet from the second gas, which is a permeate from the second stage, goes back into the feed line so that we can recycle and extract maximum methane. So this method is mostly deployed in India, where recovery we can achieve up to 97% of methane recovery, and product purity we can get up to 96-97%. And I'm just using a wrong word. We are getting this purity and recovery in our current operating plant. So this way we make sure that whatever RBG we produced by using better pre-treatment and uh, digestion process, we extract maximum out of it to produce the CBG. Next slide, please. So this is just a world view, how world is looking at the biomethane technology. So this is a study from EBA, European Biogas Association, where it has been a trend has been seen that the yellow graph shows the predominance of membrane technology in upcoming projects. So world is moving towards membrane technology. More and more developers, more and more uh, plant owners are moving towards membrane technology. So that just an overview that we as a India also moving towards right direction when we are adopting membrane technology. Next slide, please.
Next slide, please.
So this is a broader comparison, mostly qualitative comparison for PSA, VPSA versus membrane technology. So scalability is the first part. Like the zeolite has a particular quantity; they can absorb CO2 and release CO2 in next stage. So that if we want to increase the capacity, the area requirement and the number of vessels to be put on increases in proportion. In case of membrane, we still need to add additional membrane, but it can be put up in very small stage. Then it's in membrane system is pretty much open. We can see the number of membranes installed and all those things. But zeolite, we recommend that we can have a better transparency in the type of zeolite used, make and quantity used in this. Operationally, membrane system is a plug and play system. I myself have commissioned around 6 to 7 membrane system. It's very easy to commission, and the on off is easy. We can go like as low as 30% of turn down ratio, where my system can still perform better. And turn on turn off is do not impact the quality of CBG, which helps in initial stages. When during the ramp up phase, when we do not have maximum production capacity, in that stage also we can make sure that the CBG production is of required quality. And again, handling flows and different methane percentage is much better handled in membrane system. Next slide, please. So now I will touch upon the FOM and LFOM specifically in case of lignocellulosic biomass plant. Next slide, please. So this is a very comprehensive table for LCB plant. When I say LCB, it's a lignocellulosic biomass, and just consider the typical composition of any lignocellulosic biomass, which has 85% TS, 85% VS, and we have multiple VS degradation efficiency based on the technology we adopt. So here, I think it can be very well known, but I just wanted to bring down to everybody's notice that since production of compost is totally depend on how much solid we recover after the digestion. As we keep on improving our digestion efficiency, we shall expect a reduction in compost production. It looks very straightforward, but that need to be considered in all business models when we are preparing a biomass. As we want to strive towards producing more and more CBG, there will be a compromise on compost production. Also, in LCB plant, typical issues faced are high pH, high EC, because the inherent properties of lignocellulosic biomass. So this can be covered with like this suitable application of compost culture. They are not new; they are publicly available. They are available in market, but that is required to produce required quality of FOM. Next slide. And this is the this is the last slide from my presentation. It is LFOM production in LCB plant. Here, for comparison, I have included PMC, press mud cake, bagasse, which is just under thought process to produce biogas. No plant has been installed as of now, and agro residues in general. So, since PMC has a surplus water, around 75% water in it. In such plant, we can expect because of positive water balance to produce LFOM. But the other biomass, when we talk of bagasse or agri residue, bagasse we expect to be water neutral. We don't need much water, or we won't get LFOM also. But agri residue plant, where these are water negative plants, so we need to add fresh water into that. So in such plant, if it is a monosubstrate agri residue plant, we cannot expect LFOM production until like it is a business decision to add more fresh water and extract LFOM. But the plant as such, when we are operating, we do not expect LFOM production from it. Yeah. So thank you very much for your time and patience during my presentation. And let's see, I hope I was in time.
Yes, yes.
About a higher number of slides, but I try to keep it concise. Thanks.
Yes.
Thank you, sir. Thank you
You
very
finished
much.
before time. Go, Tanuj, take over. Tanuj, thank you.
Thank you, sir. Thank you very much. It was a very intuitive presentation. It's time for the Q&A session, and I invite Mr. Narsi to take over this session as a moderator.
Yeah, I'm still putting down all the questions that these guys have asked. There's a ton of questions. So you guys relax for 30 seconds, take a deep breath, think about all the good things that you have done in your life. When I come back to you guys, yeah, just 30 seconds, yeah. Lots of good questions. I'm just trying to
Sure.
figure out what are the questions I should ask you guys.
Sure, sir, definitely.
Okay, I'm going to shoot a question. Maybe then while you're answering, I can pick up the rest. One of the questions even I had, because we do a lot of work in biomass supply chain, more for the briquette and pellet sector, which is why guys from biofuel circle and all very well. So the one challenge we had when we use paddy straw in boilers is the silica content. Both paddy straw and the rice husk, both of them have silica content. It's a question that was addressed while Sai was talking, but maybe is better question since it is research in that. Will that create any problem? So a related question also is to you, Sai. You can address both together. One is on silica, one is on paddy straw. You have silica content, and when it comes to Napier grass, now it has a very high moisture content. So eventually, that moisture is of no use. The energy is only in something that is not water. So if I dry all the things, will the economics work out against paddy straw? So two questions, both one on Napier grass, one on paddy straw. Paddy straw silica content challenge, Napier grass moisture. So if the moisture goes up, is the energy content still very good? Sai.
I'll take the call on silica content of rice straw.
Okay.
So the paddy, we have to factor in that the silica is going to come into the digester. Now there are various chemical methods which can be used to take off this silica layer in the initial pretreatment method, but then the cost economics and its environmental effect needs to be studied. So for right now, since the sector is emerging in India, what can be done is have a proper digester maintenance SOP wherein the effect after effects of silica we need to counter in and accordingly prepare a strategy wherein the blades of the initial shredders needs to be changed periodically, the pre-treatment, all the setup of pre-treatment, the maintenance of it needs to be done properly. In the digester case, there is scum formation. We need to have a watch on the scum formation and need to take control measures, right? So unless the technology is developed wherein the silica gets rid of in the initial pre-treatment method, the existing things needs to be properly optimized and taken care of. In the case of Napier grass, it is right that it has a lot of moisture which is of no use. So there are various ways in which people outside India they are trying to silage the Napier grass and then transport it. So silaging compresses the Napier and vents out all the gas vacuoles that is present in the Napier. So what happens is the excess amount of moisture gets out of the Napier plant, and then the transportation economics is somewhat in the range.
Got it.
So that needs to be done on field.
But quick question, Sai. This is something which you can answer. So
Yeah.
anyway, you would require water during the digestion stage. So is it
Yeah.
high moisture preferable?
For the case of Napier,
Yeah. I
yeah,
mean, isn't it good if I put the Napier grass right into the digester instead of drying it or getting rid of the moisture? Which is better?
Yeah, if the Napier plantation is within 5
Okay.
kilometers radius of the the
Got it.
CBG plant,
Got
then
it.
the transportation economics is under control, right? So if it is within 5 kilometer radius of the CBG plant, we don't have to dry it or silage the Napier. We
Got
can
it.
directly use it as a whole plant, spread it on the site and introduce it into the digester. But in certain cases, Napier plantation is away from the digester, more than 10 kilometers away from the digester. In
And
that case, we need
you're
to
just
have
transporting water. Yeah, you're just
yeah,
transporting water. Yeah, I
yeah,
get it.
yeah.
Got it. So Sankalp, a question to you, two questions around membranes. So I clubbed them together. By the way, guys, there are lots of questions. Huh? I have to disappoint you. I cannot read out all the questions, but I will ensure I send all these questions to you guys.
Yeah, sure.
Around the membranes, so two questions, Sankalp. One is on how good is a membrane separation at removing VOC and siloxanes from the biogas, and life of membranes. So because you seem to be batting for membranes as the one you would choose, so life of membranes, also how good is it, how effective is it in removing VOC and siloxanes, and also one guy seems to feel that PSA gives better quality. I don't know what he means by quality, but he seems to be under the impression that PSA gives better quality of CBG. What are your opinions on this?
I will take one by one. So VOCs need to be removed before it is going to membrane. So typically simple system like activated carbon filter can be deployed to remove VOCs. So that is membrane. We do not expect them to remove VOCs. We take out before it reaches to the membrane.
Okay.
Second question was about membrane life. So
also siloxanes. He had mentioned siloxanes.
Siloxanes also we expect to remove.
All right, got it. Go ahead.
Next is about life of the membrane. So life of the membrane as given by the original producers of the membrane ranges between 5 to 8 years. But with a caveat that they have operated or they have data received from their client for this period. So it is totally based on the quality of biogas we inject into the membrane. We remove all adulterants from the biogas, then we can definitely expect a higher life of the membrane. So we have to, if we manage properly, we can expect much higher life. There are documentation that people have used membrane for like more than 8 years also, but OEMs do not like to give that numbers in their documentation, so we stick to that, but definitely it can be much higher than these numbers. Last question was quality. So quality in membrane with two stage, we can go up to 97%. If need to be more, it is an option to go for three-stage system where we can go up to 99.12%, and recovery also can be achieved up to 99%.
Got it. So the question maybe both of you can take because this is relevant to the core skills that you guys have. How do you, so Sai mentioned a lot of parameters in this detailed presentation, what to look for, the pH, a whole lot of things. How do you monitor continuously all these parameters? What do you do if something goes wrong? So this probably has to be the last question. As I mentioned, there are way too many. So I have to really file them and send them to you later on. But so this is a common question to both of you. I know, GPS has done a lot of work in IT. I'm sure Redis, Re-Energy Dynamics is doing as well, but not just IT alone. I think the question is, look, these are all biological organisms, and this is not like physics or chemistry. This is biology. Yeah. So yes, you can monitor quite a lot of things. You may not be able to monitor something very well, but even if you're able to monitor, how can you take corrective actions? So this is the question to both of you guys. So maybe you can start with Sankalp. Is that okay?
Okay.
Yeah.
So I will take it. So typically what we do, we just have multiple layers of observation. So certain things which can be monitored remotely, or which can be monitored with sensors. So things like how much feeding is being done, flow, what is the temperature in the digester, whether agitation is efficient or not, whether our agitators are consuming required ampere, means they are consuming required power or not. So that give a fair idea about the digestion, whether a digester is working as per our design parameters or not. The next level comes with lab analysis. So very fundamental basic analysis that we have to do on day-to-day basis is input TS, input VS, how much we are feeding, then what is the pH, VFA-TIC, which we call this as a pulse meter for the biogas plant, which give a lot of information about the digester health. Then additional is biogas composition. Biogas composition is the first thing which get deteriorates when anything going wrong in the biogas plant. and ultimately your CBG production, whether it is as per your expected yield or not. On top of that, if we sense any issues, we can send the samples outside for majorly CN ratio, and some other things can be tested is like if there is a visual observations, like if there is a foam, or if there is a natural level increase, if there is a slurry coming in your gas line. All those things are physical observation, need to be done on a day-to-day basis in the site. And if all this indicates further deterioration, then other layers of monitoring comes and other layers of analysis come, but that can be out of scope of this current discussion. But for operating a good biogas plant, the things I listed out, the lab equipped to do all those things is very much essential, and it is definitely backed by a central team which can monitor these parameters across the plant and give right guidance to the operating team.
Good. So Sai, from your side,
Yeah,
what are
I'll
things
just,
you
yeah,
can add?
most of the things are covered by Sankalp sir. So I'll just add it. What basically is, there are various parameters in the digester that has to be monitored, and it is humanly not possible to, measure everything at all given point. So what we basically do is we strategize it. So if we are trying to, commission the plant, so while commissioning phase, checking gas composition initially is of no use. So for that case, we try to see what amount of TS and VS we are introducing into the digesters. Once our plant gets commissioned properly, it reaches its final phase. Then we try to see what type of VFAs and alkalinity, what is the ratio of that. So that will indicate us whether we are feeding our digester in a proper manner or no. And once we get once we have optimized this feeding strategy, then we look towards the gas composition, whether we are getting desired amount of gas or not. So all these parameters need not be tested regularly, but some sets of parameters needs to be checked at different stages of commissioning. So in that way, we can try to limit the parameters that needs to be measured, and it becomes possible also to do and measure these parameters if we just reduce the number of parameters.
Got it. Thank you. Thank you very much. We have a lot many more questions. I mean, let me just give a gist. There are guys who have asked about, high protein content. Is it beneficial or not? Then we have questions on gas composition at digester outlet. Some people have definitely, they want to know a lot more about pre-treatment, as it's very high, a very, very high expense. Some of these probably can go to later sections. And also about, some people have actually asked more for the food waste, whether size reduction is important, something about specific bacteria and the other consortium you can use for pre-treatment. I'm just giving you just so that you can remember.
Yeah.
You know, Narsi asked me all these questions. Yeah, someday when I send you guys the email, these things will hopefully go off in your brain. How do we, whether we should use mesophilic, thermophilic treatment in biogas? So lots of interesting questions. Also, a question about Sai. You had mentioned about the latest emerging technologies. People are obviously, they're excited at the same time apprehensive. All these are looking good, but will they work only in America and Europe, or will they work also in India, where there are other challenges in economics and maintenance and things like that? All these are great questions, but they have to wait. They have to wait till we package everything. We know who asked these questions. We'll package everything and send it to you. And please do get in touch with them later on. Thank you very much.
Yeah,
Happy to answer these questions.
Yes.
All the very best.
Thank you very much
thank
for
you.
inviting us.
Yeah, thank you.
Thank you. Thank you, sir.